An engineer is designing the runway for an airport. If the plane in which will use the airport, the lowest acceleration rate is likely to be 3 meters per second squared. The lowest takeoff speed will be 65 meters per second. By the way, how many miles per hour is this? Assuming the minimum parameters for the same plane, what is the minimum allowed length for the runway? In this case, I am given that acceleration can only be 3 meters per second squared. I'm also given that this velocity down here, which is going to be my velocity final, needs to be 65 meters per second. I'm not given this, but I can assume that my velocity initial is 0 meters per second. And then it asks for what is the distance that the runway needs to be. Now, before I even start the FNEOM, if I am changing one speed, 65 meters per second, into miles per hour, that is a FNEOM problem. And so I'm going to do my FNEOM on the top here, and I have 65 meters per second, and in the end I want miles per hour. So let's see, the meters into miles. I need some conversion factors. The first conversion factor I'll use is I know that there's 1 kilometer and 1,000 meters, and this allows me to cancel meters. The next conversion factor allows me to go, there's 1.61 kilometer and 1 mile. And that allows me to cancel kilometers, which is good because I want miles. So I've done the distance measurement. Now I need to solve the time measurement. So I'm going to put up another set of field goals that allows me to go from seconds into minutes. There are 60 seconds in 1 minute. And then that allows me to cancel seconds with seconds, leaving me in minutes. And then there are 60 minutes in 1 hour. When I do the math for the top, I get 234,000 divided by 1,610. When you do the math, you find that you get 145.3461. And when I sig fig it, I get 145. And since there are two significant figures, I get 140 or 150 meters per second. When I do this math, you get 145.3461. And when I take the sig figs, two sig figs, I get either 140 or 150 miles per hour. So I've answered question 1, but now I need to figure out what the displacement of the runway is going to be. So the things that I know, we're talking about the x-axis, so velocity initial equals 0 meters per second. Velocity final, I know, is 65 meters per second. And the acceleration in the x-axis can only be 3 meters per second. The thing that I'm looking for is distance in the x, meters. And so the formula that I'm going to use is velocity final squared equals velocity initial squared plus 2 times the acceleration times the distance. So if I replace numbers for letters, I have a velocity final of 65 squared equals 0 squared plus 2 times the acceleration of 3 times distance, which I don't know. When I square 65, I get 4225 equals, the 0 blows up, and 2 times 3 is 6d. In order to get d all by itself, I'll divide by 6. d equals 704.1666 meters. And now, if I apply the correct number of significant figures, I only have 1 sig fig. So that means that my answer is going to be 7, followed by 2 placeholder zeros, meters.